Welcome to this third module. In this particular module, we will study the different type of accidents, nature of those accidents, and various disaster. Now, we are going to discuss four major disasters. In brief, the reason is that prima facie you must know that what was the problem and what are the different theories involved prior to the study of proper theories. Now, up till now we have studied in different modules about safety, what are the different type of hazard and risk at workplaces. We have performed the analysis of loss statistics, different methods to calculate the accident and loss statistics. We have studied about the concept of risk management and what are the different control measures to have this particular concept of risk management. We have a brief glimpse about the Hazardous Substance Rules 1986 and Factories Act 1948. Now, in this particular chapter, we are going to study about the nature of accident. Basically, we will discuss the three different kind of nature: fire, explosion, and toxic release. And based on that particular thing, the introduction of four significant disaster of what? Flixborough, Seveso, Bhopal and Jaipur, because these four accidents, these accidents are landmark accidents, and these accidents gave a very important information about the chemical process safety. Now, there are three most common type of accident: fire, explosion and toxic release. Now, in detail, we will discuss all three aspects in subsequent modules. Now, basically, because at this particular point of time, we must know the different type of accidents plus what are the major hazards. So, what went wrong for those particular hazards. Now, in this particular table, you will find that the type of accident fire, the probability of occurrence is on the higher side and potential of fatality is on the lower side, and the potential for economic losses is in between high and low. Now, we will discuss why all these things happen. The explosion, because of release of large quantum of energy, the potential of economic losses is on the higher side. It may not lead to the fatality on the larger segment, it may be in the range of intermediate, and the probability of occurrence is intermediate. The toxic release, the probability of occurrence is extremely low, but the potential for fatality is on the higher side and economic losses are on the lower side. Now, you can see by the evidence, because in the subsequent slides, when we go through all kind of accidents in brief, you will find that the fatalities in terms of for toxic release with respect to Bhopal Gas Tragedy was on the higher side compared to the fire in the Flixborough or a Jaipur or explosion in case of Seveso. With respect to fatalities, accident may be because of toxic release having the greatest potential. Maybe sometimes the fire may lead to explosion and sometimes explosion may lead to fire. Now, most accidents follow a three-step sequences as we discussed in module 1. The initiation, the event that start the accident. For example, somebody threw away a burnt cigarette butt into the dried bushes. Now, in that particular case, sometimes propagation may lead the event or event that maintain to expand the accident. A portion of those dried bushes ignited and releasing the thick smoke and hot flame. Fire starts to progress to another art of bushes. And the termination, the event of or event that stop the accident or diminish it in size. The consumption of combustible material in process or sometimes fire extinguishing. Now, remember, I talked about the Jaipur incident. The IOCL depot caught the fire, and that particular accident followed the three initiation, propagation and termination steps. We will discuss this thing in subsequent slides. Now, there is inherent safety. The major approach to inherent safer process design is divided into 5 different segments: intensification, that means you need to intensify the process so that the chances for any kind of fire, explosion or toxic release may be diminished. You must be in a position to substitute with the help of suitable chemicals, which are those who are less toxic, those who are less inflammable. You must give a proper attenuation. Limitation of effect you must analyze, and you need to simplify the process, or you need to simplify the error or tolerance. The four buzzwords to describe the inherent safety: the minimize, the substitute, you must substitute, moderate conditions, maybe use of low temperature or low pressure, sometimes may, of course, it may give you a low yield or low conversion, but sometimes your expenditure on the safety may be on the lower side. Simplify, you must follow the concept of KISS, keep it simple and safer. Now, before we go into detail of fire, toxic release and explosion, we must have a brief idea about the different accidents, those landmark accidents. The first one is the Flixborough UK cyclohexane disaster took place on 1st June 1974. This was purely based on the vapor cloud explosion. This Flixborough disaster was an explosion at a chemical plant owned by Nipro UK Limited, and this occurred in Flixborough, England on Saturday 1st of June 1974 at about 4:53 p.m. This particular figure is taken just immediately after the accident. Now, before I give you a brief description about the accident, let us have a product description. The raw material was cyclohexane, the formula C6H12, molecular weight 84 and boiling point 81. Now, this is a very vital information, and you can have this particular information from material safety data sheet for each and every component. Now, cyclohexane is a volatile liquid with a low boiling point at ambient conditions, something like petrol. Now, it is having the liquid density of 780 kg per meter cube, and a vapor density is 2.4 kg per meter cube. Now, this particular aspect is essential. The liquid is lighter than water, while the vapor is heavier than air. This is common with the many kind of hydrocarbon. Now, this is again a very important information, because for every accident you need to go for accident investigation so that it cannot occur in near future for the same type of scenario. So, this particular information, all these information you can have it from material safety data sheet. Now, the Flixborough works of Nipro was virtually demolished by an explosion of warlike dimension on the afternoon of Saturday 1974. The explosion was estimated to be equivalent to the force arising from 15 to 45 ton TNT. This was due to the ignition of vapor cloud, which was formed when the pressurized cyclohexane escaped from a reactor, vaporized and ignited. Now, remember, the initiation, propagation and termination, these all three things took place in that particular accident. On site, 28 people were killed and 36 injured, and if explosion had occurred during the week, there would have been many more casualties. Now, what happened, because this is the reactor battery, and this Flixborough plant, they used to produce, in this particular reactor battery, they used to produce cyclohexanone from cyclohexane. And this particular battery consisted of 6 different reactors having the capacity of 20 ton each, and all these reactors were pressurized. So, with the help of air, the cyclohexane is converted into cyclohexanone. Now, there are 4 different segments through which they can get the purified cyclohexanone: scrubber section, distillation, separator and after reactor. Now, what happened? The reactor number 5 was faulty. So, they sensed that something went wrong. So, what they did, they bypassed this reactor number 5, and they just installed a flexible pipe to connect reactor number 4 with reactor number 6. No doubt there was a very small amount of conversion loss because of the kinetics, but simultaneously it is extremely dangerous in nature. We will go in detail when we discuss about this particular accident in detail attributed to the accident investigation. But without much loss in yield, they bypassed the things, and it took around 2 months, because 2 months prior to the explosion, cyclohexane, they discovered that there is a leaking because of some variety of reasons. So they detected a leak, and they decided to bypass like this. Now what happened? Because of the pressure fluctuation, this particular pipe was dislocated, and 80 ton of cyclohexane or mixture of cyclohexane and cyclohexanone was exposed to the atmosphere, and it created a vapor cloud, and the source of ignitions was enormous at that particular point of time, and somehow this particular vapor cloud got ignited, and it is just like a fire cloud. So as a result, 28 people killed and 36 seriously injured. The record and charts for the startup were destroyed. Fire remained burning for over 10 days because they did have a large quantity of inventories in their store, warehouse. Large quantity means cyclohexane, cyclohexanone and other allied products. They are having the other flammable product. They are having the large quantum of those inventories. Property damage, this extended over wide area. More than 1,800 buildings within 3 miles radius of the site were damaged. Blast heard till 30 miles away. Now reason was the pressurized vessels, they were exposed to the atmosphere, and cyclohexane is extremely flammable in nature. Now you can evident through the previous data given in the previous slides. Now after accidental analysis, they found out there are certain points, that is, changes to the design should be overseen and authorized by a properly qualified person. The carry out systematic search for possible causes of the problem before any modification process being done, because unfortunately they didn't carry out any kind of pressure and temperature analysis for this particular modification. Knowledge and understanding of hazard of the process might have prevented the accident from occurring. Another toxic release accident attributed to the Seveso dioxin pollution, it happened in 1976. This was an extremely serious accident, happened in 1976 in a small chemical plant located not very much away from Milan. It is known as the Seveso disaster, and prior to Bhopal disaster, it was termed as the most serious disaster in the toxicological studies. This industrial plant owned by a Seveso company, a subsidiary of Guyardin, which is in turn was subsidiary of Hoffmann de la Roche. It's a famous chemical company. The plant was built many years before the accident and was manufacturing dioxins. Dioxin are a more serious component to the humankind. Now, due to the mechanical failure, the temperature rose to around 300 degrees Celsius, and relief valve eventually opened. 6 tons of material, including 1 kilogram of TCDD, tetrachloro-dibenzo dioxin. This is more extremely toxic in nature for the human being. It was released over 18 square kilometer area. Dioxin, it first came into widespread public notice during the Vietnam War, when it was identified as a component of defoliant agent orange. Previously, the substance had been banned from agricultural use because of its alleged toxic effect on humankind. Now, the safety measures, because this is again the slack negligence from the company official point of view, because it was a 2-step process. First step is usually carried out at a stipulated temperature, and there was a necessity to lower down the temperature by the addition of water, and it was neglected by the plant official. That is called of human error, and it was neglected. Once it was neglected, the temperature remained at 150-60 degrees Celsius, and due to the thermal runaway reaction, the temperature rose up to 300 degrees Celsius, and all the safety devices failed at that particular point, because the reactor was not designed to handle such type of scenario. So all TCDD, which is in very low quantity in the discharge, but obviously because it is extremely dangerous to humankind, it released into atmosphere. So the safety measures and the cleanup and restoration, the safety measure taken by the company and the authorities were badly coordinated. In the previous module, we have discussed about the responsibility of the occupier as well as the responsibility of authorities. So at least a week passed before it was publicly stated that a dioxin pollution occurred, and another week passed before the evacuation began. Now, within a days, a total 3,300 animals were found dead, mostly poultry and rabbits. Emergency slaughtering started to prevent the TCDD from entering into the food chain of human being. And in 1978, over 80,000 animals had been slaughtered. So you can imagine that it took around 2 years to completely restore and clean up the things based on this particular discharge. Then a lot of judiciary cases were filed. In 1980, the director of production of the company was shot by a member of terrorist organization because it was an outcome of that particular incident. A few months later, the compensation agreement was signed by the representative of reason, the president of the Italian Republic, and the company officials. The total amount of agreement was about 20 billion lira. The technical director of the company was sentenced to 5-year imprisonment in the first degree trial, and then had his sentence reduced to 2 years and was paroled on appeal. Now the third major accident is Bhopal Gas Tragedy. You can see the severity of that particular accident. This was occurred on 3rd December night 1984, and the company who owned that particular plant was Union Carbide Corporation, and the chemical which was released was methyl isocyanate, and it was released in the quantity of say 20 to 30 tons. Now the severity you can see in this particular slide, that 500,000 people were exposed to the gas. 25,000 have died to date as a result of this particular exposure. This is an approximate figure. More than 1,20,000 people still suffer from different type of ailment caused by the accident and the subsequent pollution at the plant site. This may be attributed to the gene changeover because MIC is again more prone towards the change in the genes. These ailments include the blindness, extreme difficulty in breathing, and different type of gynecological disorders. Now this site has never been properly cleaned up, and it continues to poison the residents nearby. We will discuss this Bhopal gas tragedy in detail with due attribution to accidental analysis. Now Union Carbide Corporation, they started their activity in Bhopal in 1969, and the material they used, the phosgene, monoethylenamine, methyl isocyanate, and pesticide carbaryl, and they used to produce the pesticide commercial name as 7. It was taken over by the Dow Chemical in 2001. Unfortunate part is that Dow refused to take the Union Carbide's liability in Bhopal. Now see, almost 25,000 killed, and still 1.2 lakh severely affected. Still they are suffering, and we thought that only weapons could cause the mass destruction. This is the mass destruction. The Jaipur Terminal Fire, it happened on 29th October 2009. IOCL, they are having this Jaipur terminal, and in addition to this, the plot accommodated the facility for pipeline division, which operate the cross country because it was on the pipeline grid. The Koili Sanganer product pipeline feeding that particular terminal. They are having the marketing terminal occupied 105-acre land, and the pipeline division facilities were located in 15 acre in the northeast corner of the facility. Now there was a sudden release of petrol and diesel from this particular facility, and a vapor cloud was formed, and somehow this vapor cloud got ignited, and initiation took place. Now, because of the combustion of these petroleum product, a lot of heat being liberated, and because of this, because of delta H, enthalpy content of those petroleum product. Now, because of the net release of energy, all other tanks, they got heated up and vapor cloud tends to form. Now, because of this vapor cloud, the propagation took place because through conduction, through auto ignition or through radiation, these remaining tanks, they got ignited and propagation took place. And plant officials were not in a position to control these things. So, termination could not be possible at the moment, and they followed the let it go policy. So, they waited for a long period to consume all the petroleum product within the plant by the fire. So, about 60,000 kiloliter of petroleum product is stored in that particular terminal at the time of accident, and the installation was totally destroyed. Buildings in the immediate neighborhood were heavily damaged, and minor damages and window panes breakage occurring up to 2 kilometers from the site. You can see the gravity because the formation of vapors attributed due to the heat. So, the total loss estimated on account of fire and explosion as reported by Indian Oil Corporation in press, which includes the loss of finished product, stores, fixed asset and compensation for third party losses amounted about rupees 280 crores. 11 people within the site lost their lives in the accident, 6 from IOC, 5 they were outsider and several others were injured. So, this is the true example of initiation, propagation and termination. And termination, usual control measures, they didn't work. They were not in even a position to control that particular fire because of the generation of a lot of heat. So, overall lesson learned based on the Jaipur incident, the few lessons are learned, they are highlighted, like facilities and installation with the inherently high hazards should incorporate redundancy in safety systems and ensure their upkeep at all times. Management should ensure that reliable systems are in place to give timely feedback on the current practices and state of readiness in different facilities. Management must ensure that identified actions are being carried out. A high priority on safety from the senior and top management group will send the right signal down to the line to ensure the safety and production. Now, in this particular module, we have studied about the safety, different accidents. We have studied about what are the major things in the safety, things like fire, toxic release and explosions, etc. In the subsequent modules, we will discuss all these things in detail. Thank you.